For a sketch, the x and y intercepts and sometimes the turning point are needed. The x-intercepts occur when y equals naught, so substitute y equals naught into the quadratic equation to obtain x squared plus 3x plus 3 equal to naught. The equation does not factorise, so use the quadratic formula. Compare the quadratic with the general equation to find a, b and c. So a equals 1, b equals 3 and c equals 3. Substitute these values into the formula. b equals 3, so the first term in the formula becomes negative 3. The second term, b squared, becomes 3 squared. And 4ac becomes 4 times 1 times 3, which is written in brackets, so the minus can be dealt with later. Finally, substitute a equal to 1 in the denominator. Note that the whole of the numerator is divided by the denominator. Simplify by evaluating the brackets first. 3 squared gives 9, and 4 times 1 times 3 gives 12. And finally, the denominator is 2. The square root of 9 minus 12 is the same as the square root of negative 3. Since it is impossible to find the square root of a negative number, values of x cannot be found. Therefore, there are no x-intercepts. The y-intercept occurs when x equals naught, so substitute x equals naught into the quadratic. This gives terms which evaluate to naught, and so y equals 3. Therefore, the y-intercept is at point 0.3. This is plotted on the sketch. Remember, there is no intersection with the x-axis, so the quadratic curve must lie above it. The curve passing through the y-intercept could look like this, or this, or even this. In fact, the number of possibilities is infinite. The correct sketch can be found if we find the turning point. The gradient of the curve at any point is equal to the gradient of the tangent at that point. The tangent at this point has a positive gradient. The tangent here has a negative gradient. At this point, the tangent has a 0 gradient. The point represents the turning point of the curve. By finding the derivative of y, referred to as dy by dx, the gradient at any point on the curve can be found. Each term in the quadratic is of the form ax to the n. A is a constant and n the power of x. The term ax to the n can be thought of as a times x to the n. To differentiate, multiply the constant a by the power n and decrease the power of x by 1, giving the derivative of y as an x to the n minus 1. Differentiating the first term in the quadratic, thinking of the term as 1 times x squared. Multiply the constant 1 by the power 2 and decrease the power of x by 1. Simplify to obtain the derivative, which is 2x. So the derivative of the quadratic starts with 2x. The second term in the quadratic is 3x. Writing x to the power of 1 and then 3 times x to the power of 1, and differentiating, multiply the constant by the power of x and decrease the power of x by 1. Simplify to give 3x to the power of naught. Since x to the power of naught is the same as 1, the differentiation of this term is 3. So now the derivative comes to 2x plus 3. Finally, the last term, which can be thought of as 3x to the power of naught, since anything to the power of naught is 1. Writing 3 times x to the power of naught. Differentiate, multiply the constant by the power. This in fact gives 0. Decrease the power of x by 1, and still obtain 0. So the derivative of the quadratic equation, dy by dx, equals 2x plus 3, which represents the gradient at any point on the curve. The gradient at the turning point is 0, so dy by dx equals 0, giving 2x plus 3 equal to 0. Solving to find x. First, subtract 3 from both sides. The 3's cancel out to give 2x equal to minus 3. Dividing both sides by 2 and cancelling gives x equal to negative 1.5. So the x-coordinate of the turning point is negative 1.5, which is plotted for reference on the x-axis. The turning point must be below the y-intercept, as it is a minimum point, and above the x-axis, as it does not intercept it. So the quadratic curve could look like this, or this, or this, or this. In fact, there is an infinite number of curves that it could be. Clearly, we need to find the y-coordinate of the turning point, so substitute x equal to negative 1.5 in the quadratic equation. Using brackets ensures that it is negative 1.5 that is squared. Evaluating the brackets. Then any addition and subtraction to obtain y equal to 0.75. And marking on the sketch. So the turning point is negative 1.5, 0.75. And the quadratic curve can be drawn. Adding the equation of the curve completes the sketch. In this video, b squared is less than 4ac, giving the square root of a negative value, which cannot be evaluated, so the curve does not intersect the x-axis.